one T than the other? Who remembers from that? Landon. Yeah, whichever original costs closer to what we want our goal cost to be. So we knew that we were going to have more hibiscus tea because 12 is closer to 25 than 40 is, right? So that's just something to keep in your mind. So when you get to your answer, if that isn't the case, then you know you made a mistake, right? Some of us got a little thrown off here because we had negatives, but it all worked out. Yeah? And then we started the chemistry with these cute little buckets. Right? You guys were like, wow, those are amazing. You were really impressed with my bucket drawing ability. They don't have handles. Do you guys want me to put handles on them? I put some handles on them for easy carrying. There we go. Now they're really buckets. Okay, so we had a certain percentage of acid, right, concentration levels, and we wanted to make 500 liters at 55% concentration. So how much am I going to need of each type to get this amount? So similar to our other examples, we have our equation right here. Right? So we're going to have 0.25x plus 0.75 times the quantity 500 minus x, and that will equal 0.55 times 500. Where does this 500 minus x come from? Where did that come from? Avery?
The amount of 75%.
Right, but why is it 500 minus x? Why did we decide that this was going to represent how much of the 75% we needed?
It came from the finished mixture.
What's x? The 25%. So 500 minus the 25% will tell us how much of the 75% we need, right? So then we're just going to solve this like normal. 0.25x plus 375 minus 0.75x equals 275. We're going to get negatives again, but it's okay. We'll all even out. So I've got the 0.25 minus the 0.75, so I get negative 0.50x plus 375 equals 275. Then I subtract the 375 from both sides. So after all that fancy mathing, I determined that x equals 200. So how does that relate back to the original question? What does that mean? Eden.
25% acid solution is 200 liters times the 500 liters.
Great. So that means we need 200 liters of 25% concentrated solution. And then how many liters of the 75% do I need? Based on my 200 liters for my 25%. What do you think, Addison?
300 liters of I mean,
Yeah.
75%.
Because we know that 200 plus 300 will give us that 500 in that last bucket that we're hoping for. You okay over there? Okay, we saved the best for last. Give yourself a second to read example 4. Bless you. It's a little different. We're adding water to a salt solution to basically make it less salty, right? Water kind of neutralizes the salt. So the weird thing about this one is we don't know how much we're going to have of the final solution, right? So this column here is going to be totally different because it's not going to be a something minus x, because we don't know what that new mixture, how much we're going to have to make it. So we're going to do some baby steps here. We're going to draw a picture. What's the salt content of water? Well, just in general, water out of the tap, how much salt is in there? You would hope 0, right? And then they tell us that our salt solution we're given has 40% salt in it. And we want the mixture to have 25%. So what we have is how much of the water do we have to add to 400 milliliters to make this new mixture? So we're still given bits and pieces, just not the same that we've been working with up until this point. So then we fill in our table, percent of solution that is salt. Well, 0 is 0. What we're given is 0.40. What we want is 0.25. We don't know how much water. We know we have 400 milliliters of the salt solution. So we're going to add those to figure out how much of our new mixture we're going to end up with. So 0 times x is 0, right? The x doesn't even make it past this stage. Anything times 0 is 0. And then we have 400 times 0.40% of the mixture. 0.25 times x plus 400, right? So I did this here and that there. And now I'm going to do the exact same process. I'm going to bring that equation down.
You have to put 0.
I only did as a placeholder, just so you guys can see, like, oh yeah, I took this plus this equals that. So that you weren't like, hey, where'd the 0 go, right? If you are fine not putting it there, that's okay. But some people are like, where'd the 0 go? Like, where'd it go? Why did you get rid of the 0? So certainly don't want to confuse anybody. And now when I solve for x, I just subtract 100 from both sides. Divide by 0.25. What does that 240 represent? What does it mean in the context of this situation? Where are we headed? What is it? How does it relate back to the big picture here? What do you think, Hayden?
The amount of water you need in milliliters.
Yeah. So I have 240 milliliters of water, but the question was, what will the total volume be of the new solution? So that is what this represents, but then how do I have to take this a step further? What do I have to do? Jackson?
The water.
Add it to the salt solution, right? Because X is water. We know our salt solution. So we have 640 milliliters of new mixture. Ta-da! Exciting, yeah? You guys ready for lunch?
Yes.
Okay. We'll continue this fun after lunch.